Good morning, dear students. Good morning, all of you. So, this is a video of class 10, and in this video, we are going to discuss about the conceptual questions. The very first question you can see, what are the two properties of carbon which led to the huge number of carbon compounds we see around us? As you know, dear student, a number of compounds which we actually see daily in our daily life that actually made up of carbon. Whatever we are actually wearing clothes, whatever we are eating, again, near around us also, what cooking, what the fuel we are using in the vehicle, in the cooking cylinder, everything we are talking about the carbon. So there are a large number of compounds which is actually made up of carbon. Why carbon actually forms such a large number of compounds? Okay, now, so here are some of the properties of carbon, and that you can see. That one is catenation, tetracovalency, small size of atom. These three are responsible, although in the question they have asked about the two properties. Okay, now, but you can see the tetracovalency, small size of atoms, catenation. What is this catenation and what is tetracovalency? What a small size of atom, you should know. As the electronic configuration, if you write 2, 4 would be there, and in SPDF you will write, yes, they do not have d block element, d block electron. So we can say that's atom which do not have d block electron, that is considered to be the small atom. Okay, a small size of atom. So here you can see that we will talk about the catenation first of all. Catenation means self-linking ability. Catenation means self-linking ability. Ability of what? Self-linking. Self-linking means what? Means carbon. If I am talking carbon will combine with other element of carbon, means self-linking. Carbon is combining with carbon and forming a bond, single bond, double bond, triple bond, whatever. If I am talking about that uh, self-linking ability of nitrogen, so nitrogen will also combine, but there would be some problem. Self-linking ability to form a straight chain, branch chain, okay na, and ring chain also is actually shown by this carbon at a larger extent as compared to nitrogen, as compared to other element. So catenation you have understood, self-linking ability of the element, self-linking ability of the elements. Carbon shows catenation at the large extent, but nitrogen, bromine, sulfur, phosphorus will show the catenation at the less extent. Why it is so? Because in the carbon it will combine because of the strong covalent bond formation, strong networking, compact arrangement, and carbon will form a bond with carbon that cannot break easily, that form a strong network that cannot break easily. But if I will take nitrogen 4 or 5 nitrogen, after some times it will break again. So you will never see that N4 is there, N5 is there, okay na? But you can see carbon 60 is there, carbon 350 is there, okay na? So that self-linking ability of carbon is known as catenation, and it actually, after the catenation, it will give you the long straight chain, branch chain, ring chain, okay na? Then after tetracovalency, if I will write the structure, electronic configuration, so you can see electronic configuration of carbon is 2 comma 4, and this 4 electron, if I will write here the electron dot structure of this one, 4 electron, this is not stable, oh sorry, this is not there. 4 electron is there, 4 dot is there na? That means 4 electron, and that 4 electron or all 4 electron can share with other element, suppose with the hydrogen also, suppose with the chlorine also. Then covalency means it is actually forming 4 bond with other element share. And small size of atom we have discussed about that one, okay na? So we have seen that one, sorry. Okay, now the next one is graphite is soft to touch, give reason. Graphite is soft to touch, why? Give reason. You can see that if I will draw a structure of graphite, I will draw this kind of structure. One layer, then second layer, then third layer. Oh, one, two, third, and again you can draw, okay na? Again and again you can draw. This layer type of structure is there in the graphite, and that is soft. Why it is soft? Because of its sheet like structure, okay na? Sheet like structure, where you can see that carbon atoms join together through weak van der Waals forces, okay na? So that weak van der Waals forces can break easily, and when we are touching that one, it will behave like a soft. You can see one black lead of pencil, it is very soft, and even with the hand also you can break that one, soft, okay na? So because weak van der Waals forces are there, okay. Then after, explain the versatile nature of carbon. Catenation we have discussed about. Versatile means what? It shows a high reactivity with different elements, okay na? It shows lots of characteristic properties to react with other elements. C can react with carbon, can react with oxygen also, carbon can react with nitrogen also, carbon can react with chlorine also, hydrogen also. Lots of versatility it actually shows. So what are the reason? You can see, first, versatile catenation. I will not go and discuss about the catenation, because in the first slide we have discussed about catenation. Tetracovalency also we have discussed. Tendency to form multiple bond, yes, you know na, dear student. Tendency to form, C can form single bond, C can form double bond, and C can form triple bond, okay na? Other C, okay, other C also with its own element also, and with hydrogen also, with oxygen also. So with different element, it is actually forming single bond, double bond, triple bond. So tendency to form multiple bonds, and this isomerism is one of the reason. Isomerism is a phenomena in which the organic compounds have similar molecular formula but different structural formula. We will not go and discuss about this one, because this is reduced, this comes in the reduced part of the syllabus, okay na? So we can see that catenation, tetracovalency, tendency to form multiple bond, and isomerism would be there. That actually explain the versatile nature of the uh, carbon, okay. Now write all the properties of graphite. What are the properties of graphite? Graphite, as you know, dear student, as compared to this properties of graphite as compared to diamond, they are talking. Graphite has medium density. Why graphite has medium density? Because it is not compact as in the diamond, because you know, in the diamond the bond distance between the two carbon atom is 154 picometer, but in the graphite the bond distance between the two carbon is 340 picometer, 340 picometer. So bond distance is slightly longer. If slightly longer bond distance would be there, that means one carbon is at some distance. You can see here the distance, you can see carbon in one structure. This one is for graphite, and if I will write for diamond, this one is for diamond. Here the bond distance between one carbon and two carbon is 154 picometer, and from here to here 340 picometer. You know, large bond distance would be there. And if the large bond distance would be there, the minimum number of carbon will occupy the space, and if the minimum number of carbon will occupy space, that means it has medium density. Okay now, and we also have discussed about that one, that it is a good conductor of electricity. Yes, the fourth electron will not uh, take part in the bond formation, and it will free to move here and there, and that's why this is the reason why it conducts electricity. It is soft and slippery. The reason is same, sheet like a structure. It is opaque and black, pencil lead is there, and it is opaque and black, and that means it cannot reflect the light. Okay, now black means cannot reflect light, opaque means cannot. Okay, opaque and black means black will absorb all the light. Okay now, so it cannot reflect the light. It is brittle in nature, as you know now, weak van der Waals force of attraction. So easily take black lead from the pencil and easily break that one. Brittle in nature, breaking, that means brittle in nature. Okay, dear student, so this is all the properties, all the conceptual questions in we have done. Okay, thank you all of you.